Okay, and then this packet is just strictly note-taking, okay? Now we start to see multiplication operators. So here's what I do. These problems are very easy. You just multiply the large numbers, 4 times 7. 4 times 7 is 28. And then you put x behind it, and you got x to the third and x to the sixth. So x to the third, don't write this down, but that means there would be 3 x's cloned and times, and then x to the sixth would be 6 x's cloned. Now, we don't usually clone variables because it's a waste of time, but I'm doing this to make a point. Now, how many x's do you see? 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, what can you do with 3 and 6? What operation do you do with 3 and 6 to get 9? I think you add them, don't you? That's what we're going to do. 3 plus 6 is 9, okay? You need to add them right there. 28x to the 9th power is the product. Here's another times. So we're going to take 3 times 5. That's 15. For the x's, we want to add, not times the exponents. We times the large numbers, but not the exponents. 2 plus 3 is 5. So in multiplication with exponents, we add the exponents together. And I illustrated y up there. Okay, now you got negative 7x to the 4th times x to the 7th. So if there's no number in front of that, we're going to put a 1. So I'll be multiplying negative 7 by 1, and that's negative 7. And I put an x behind it, and I take 4 plus 7, which is 11. Negative 7x to the 11th power is a product. Okay, next problem, we got multiplication. I have negative 10x to the 2nd as the first factor. Now, I would like a number here so I know what to multiply the negative 10 by, and that would be a 1. Okay? So negative 10 times 1 is negative 10. Now on the x's, you have a 2, but that x doesn't have an exponent. So you put a 1 there. Then 2 plus 1 is 3. So negative 10x to the 3rd. So when you don't see a number and you want one there, use 1. Okay, now on the back side, 7x times x to the 4th. So here's my multiplication. I have a big 7, but I'd like a big number here, so I know what to multiply the 7 by. It's going to be a 1. So 7 times 1 is 7. Then on the x, well, we have a 4th power here, so I'm going to put a power of 1 here. So 1 plus 4 is 5, so 7x to the 5th, because there's a factor of x there and a clone right there. Okay, negative 18x to the 4th times 2x. So again, here's my multiplication. So I can multiply negative 18 times 2. And that's going to be negative 36. Okay, then on my x's, I have 4, a 4th power, and then that would be a 1 power. So what's 4 plus 1? It's 5. Okay, another multiplication. I've got 24 times 3. That's easy enough to see. That's 72. And for the x's, we have x to the 3rd, but this x doesn't have a power, so it's a 1. Okay, so 3 plus 1 is 4. 72x to the power of 4. Okay, multiplying here. So 8 times 5, that's not hard to see. 8 times 5 is 40. Okay, now look at your x's. Now neither one of them have powers, so what powers can I put on both of them? 1 and 1. And 1 plus 1 is 2. So 40x to the 2nd. Okay, then on the back page, I multiply negative 4 by 2, that's negative 8, and then x, and then 2 plus 4 is 6. Okay, 7x to the 2nd times 10x, so the 7 can be multiplied by the 10. Okay, it's multiplication, that's 70. And then for x, we have 2, and this x would have a 1. So 2 plus 1 is 3. In multiplication, you have to add the exponents. Okay, another times operation. So negative 3x to the third times x. Okay, we need a number we can multiply negative 3 by, so it would be 1. So negative 3 times 1 is negative 3, and then x. But I have a third power, and that x doesn't have a power, so that's a 1 power. So 3 plus 1 is 4. Okay, and then the last one, 18x to the second times x to the ninth. So let's put a big number there so I have something to multiply the 18 by. 18 times 1 is 18. X, and then we take 2 plus 9, and that's 11. 18x to the 11th power. Okay, now the back page, the game changes. Find the product. Here's what you do. First off, if you have this, this is called a monomial here. There's only one term, one thing. So what you're going to do is just leave it there. And you're going to put a multiplication dot there so you know what you're multiplying. So what we need to do here first off in multiplying is we need some rainbows, okay? I have this monomial 2x to the third here, and then I've got x to the third plus 3x to the second minus 2x plus 5. What I need to do with this 2 is distribute it to everything in here with my rainbows, okay? So the first thing I do is make sure, before I'm about to draw my rainbows, I want to make sure every x I have has a number in the very front of it, okay, before we draw our rainbows. So that x has a 2. That x has nothing, so that'd be a 1. That x has a 3. That x has a negative 2. So now we're good. Okay, you want it before you go multiply, you're going to need to check that. This is totally different than the adding and subtracting operation you did. Multiplication's a totally different procedure. So the first thing I do is distribute 2 to 1, and then I go over here and I write 2 times 1. Now the 2 had an x to the third, and the 1 has an x to the third. Okay, so we take 2 times 1, that's 2, and on the x, 3 plus 3 is 6. Okay, we're not done. Now we need to distribute the 2 to the 3, okay? So it's 2 times 3. Now the 2 has x to the third, and the 3 has x to the second. So I take 2 times 3, that's 6. And on the powers, I put x, and 3 plus 2 is 5, okay? Then I take the 2 again and distribute it to the negative 2. That is negative 2. So it's 2 times negative 2. And the 2 has x to the third. And the negative 2 just has x. So I take 2 times negative 2, which is negative 4. Then on the x's, I have a 3. And that x would need a power, it'd be a 1. So what's 3 plus 1? That would be 4. Okay, and then finally we have to distribute the 2 to the 5. So it's 2 times 5. Now look at your variable factors. You have x to the third on the 2. And you don't have a variable on the 5. Okay, the 5's naked. That's what I like to say. So I take 2 times 5, which is 10, and on the x, this is the only x I have. It is to the third power, so the x and the product's to the third power. Now I want you to look at these. Look at all your x's. Are all the powers the same, or are they different? They look like they're all different. So then if they're all different, I just simply write 2x to the 6th, plus 6x to the 5th, just plus, plus negative 4x to the fourth plus 10x to the third, okay? And that's your product. It's kind of confusing. Okay, now the next one, I'm going to write a lot smaller starting now. I wrote that nice and big so you could see it. Now, this means multiplication. Put a dot there. So with the multiplication, you need to make sure all your x's have a number in front. So that x would need a 1. That x already has a 7, so I'm pretty much good. So I distribute 1 to 7, and that's 1x times 7x to the second. Okay, then I distribute the 1 to the 4, so it's 1x times 4. So it's only two products I need to find here. Much shorter problem than up here. Okay, so 1 times 7 is 7. And on the x's, this x doesn't have a power, so it would have a 1, okay? And then 1 plus 2 is 3. Now, 1 times 4 is 4. And this x doesn't have a power, so it's a 1. And then that 4 doesn't even have an x, so this is the only x I have. It is to the first power, so I just put the first power. Now look at your x's. The powers are different, both of them. So I write 7x to the third plus 4x to the first. Now in your answer, if it's to the first, you can get rid of that, okay? I guess you don't need the first power, but put it there for now. Okay, then my next problem. X to the second power, and then the operations times, and then 6x to the second minus 3x minus 1. Now, before we multiply with the rainbows, we need to make sure all of our x's are covered. Have a number in front, so that would be a 1, okay? So here's my 1. I distribute 1 to 6, so it's 1x to the second times 6x to the second. Okay, now I go back to the 1 and I distribute it to the negative 3. So it's 1x to the second times negative 3x. You got to get the 3 as a negative. Okay, and then again, 1 times negative 1, but it's 1x to the second times a naked negative 1. So 1x to the second times negative 1. Okay, so I find these three products then. 1 times 6 is 6, and then 2 plus 2 is 4, so 6x to the fourth. 1 times negative 3 is negative 3, and that x has a 2. This x would get a 1 then. 2 plus 1 is 3. Okay, 1 times negative 1 is negative 1. That x is to the second, and there is no x here. So I just have an x here. It is to the second power, so my product is to the second power. Keep it to the second. All the powers are different, so we just write all these out with plus signs. So 6x to the fourth plus negative 3x to the third plus negative 1x to the second. Okay, and that is my answer. All right, the last one. Now the variable's a little different variable here. So we have multiplication. Now make sure all your a variables have numbers right in front. Negative 5, that a has a 4, and that a has a negative 3. Okay, so we're ready to do this. Okay, so negative 5 times 4 would be negative 5a to the third times 4a to the fourth. Okay, I'll figure that product out in a bit. I like to figure out my products after I have everything lined up. Then I distribute negative 5 to negative 3. So we're going to have negative 5a to the third times negative 3a. Okay, and then finally, negative 5a to the third times positive 1. Now let's figure out the products. We multiply the big coefficient numbers. Negative 5 times 4. That is negative 20. And then A, I add the powers. 3 plus 4 is 7. Don't multiply the powers. Okay. Negative 5 times negative 3 is positive 15. Okay. And then A, you have A to the third. And this A right here would be to the first then. So 3 plus 1 is 4. And then I take negative 5 times 1. That's negative 5. And this is the only A I have. It is to the third power, so the A product is to the third power, the same thing. Now, all of these powers are different, so we just write our answer using plus operators. So negative 20, A to the 7th, plus 15, A to the 4th, plus negative 5, A to the 3rd. Okay. Now, as far as what would you do if they were to the same power, a couple of them? Well, I'll teach that next video.